In this video, we will continue to look at CSEC Advanced past paper questions, and specifically we'll be looking at questions 1 and 2 from 2021. So this is questions 1 and 2 from 2021, paper 2. That would be section 1. All right, let's begin. So number 1, part A says determine the remainder. So determine the remainder when f of x equals ax cubed plus 7x squared minus 7x minus 3 is divided by x minus 1. So first of all, let's write down f of x. So say f of x equals ax cubed plus 7x squared minus 7x minus 3. Now, if you remember the remainder theorem, according to the remainder theorem, the remainder when any polynomial is divided by x minus a is given by f of a. So since we're dividing by x minus 1, we simply say x minus 1 equals 0, which means that x is equal to 1, and the remainder r is obtained by evaluating f of 1. So once again, according to the remainder theorem, whenever we want to divide a polynomial by a linear, say x minus a, we set that to equal to 0. We solve for x and we find the remainder, right? So what this means is that we're going to evaluate f of 1. So f of 1 would be equal to a times 1 cubed plus 7 times 1 squared minus 7 times 1 minus 3. So f of 1 is equal to a plus 7 minus 7 minus 3, which gives us a minus 3. So therefore, the remainder when f of x is divided by x minus 1 is a minus 3, right? So we don't know the value of a as yet, so we just have to leave the expression as it is. So that was part A1, 2 marks. Now it says if the remainder when f of x is divided by x plus 3 is equal to the remainder determined in ai, find the value of a. Now read this again. If the remainder when f of x is divided by x plus 3 is equal to the remainder determined in ai, which is what we just determined, find the value of a. So what they're basically saying is that the remainder, I'm going to write it out in words, the remainder when f of x is divided by x plus 3 is the same remainder when f of x is divided by x minus 1, and that of course is equal to a minus 3. So from the remainder theorem, the remainder when f of x is divided by x plus 3 is given by f of negative 3. And so basically what they're telling us is that f of negative 3 is actually equal to a minus 3, and that should allow us or enable us to find the value of a. So let's go ahead and now substitute for f minus 3 into f of x. So we have a times minus 3 cubed plus 7 times minus 3 squared minus 7 times minus 3 is equal to a minus 3. And we go ahead and we try to simplify. Now minus 3 cubed, that is minus 27. So we have minus 27a. Then we have plus minus 3 squared, that's positive 9. Positive 9 times 7, that's plus 63. Then we have minus 7 times minus 3, that gives us plus 21 minus 3, that is equal to a minus 3. So we have minus 27a. Now 63 plus 21, that is what? 84. 84 minus 3 is 81. So minus 27a plus 81 is equal to a minus 3. So let's bring all the a's to one side, all the constants to the other side, and then solve for a. So we can say that minus 27a minus a equals minus 3 minus 81. So we have minus 28a is equal to minus 84, or we can say that 28a is equal to 84, and this simply means that a is equal to 3. So there we have it, a is equal to 3 based on the conditions that were given, all right? Good. So that was part A of the question. Now let's move on to part B. Now, part B says, once again, we must ensure to read the question properly. So read the question at least twice before you start to answer or before you attempt to respond to what is being asked. So consider the function g of x equals x squared plus m plus 4 times x plus 4m equals 0, which has real and equal roots. So we're told it has real and equal roots. Use the discriminant of the given equation to determine the values for m. You may use the grid provided to assist you. So the operative word is you may use the grid. You won't necessarily have to use the grid. But let's proceed to trying to do this question and see if we need to use the grid or we don't need to use it. So let's write down the quadratic. We have the quadratic g of x equals x squared plus bracket m plus 4 times x plus 4m equals 0. Now, of course, we should be able to recognize that this is a quadratic equation. And so we can write g of x is equal to ax squared plus bx plus c, and let's say that is equal to 0. Now, if we compare the coefficients or equate them, we see that a is equal to 1, b is equal to m plus 4. Of course, that is a coefficient of x. And the constant c is equal to 4m, right? So by writing down the given quadratic and expressing it or comparing it rather to the general form of the quadratic equation, we're able to equate the constants a, b, and c in terms of numbers given in the quadratic, right? So let's proceed. Now, they basically told us that this quadratic has real and equal roots, and we must remember exactly what that means. Now, we're talking about the discriminant of the quadratic, and you must remember for real equal roots, the discriminant b squared minus 4ac is equal to 0. So whenever the roots of a quadratic are real and equal, the discriminant b squared minus 4ac must equal to 0. So let's proceed by doing this and see if I can actually find the value of m. So let's write it down. We can say that b squared minus 4ac is equal to 0. So we have m plus 4 all squared minus 4 times 1, which is the value of a, and then c is 4m, and this is equal to 0, and we'll proceed to solving for m. Now at this level, we should be able to expand something like m plus 4 all squared without going through the little baby steps. But anyways, this will give us m squared plus 8m plus 16, right? So you square m to give you m squared, you square 4 to give you 16, you say m times 4 is 4m, but you're multiplying that twice. So you multiply that by 2, that gives you 8m, right? So m squared plus 8m plus 16. So remember, is this squared, the first one squared, plus the second one squared, plus 2 times the first times the second, that will give you that, the expanded version of that. And then now we have minus 4 times 4m, that is minus 16m, is equal to 0. So let's see what this gives us. We have m squared. Now 8m minus 16m gives us minus 8m plus 16 is equal to 0. Now, what does this factorize to give? It looks like it's going to give us m minus 4 times m minus 4 is equal to 0. So we get a quadratic with a repeated root, right? And this therefore means that m is equal to 4. So with that said, we've got the value of m for which this quadratic has real and equal roots. And of course, we did not need the grid. I really don't know under what circumstances we'd need the grid, but of course, we were able to solve the question without using the grid, right? Yes. So, yeah, we did not need the grid. So let's move on to the next part of the question. So that was part B of the question, right? Now let's look at part C. Part C says, let h of x equals 2x squared plus 8x minus 10. Express h of x in the form a x plus b all squared plus c. Again, when we see an expression in this form, It basically means that we're supposed to complete the square, right? We're supposed to complete the square of this quadratic, so let's proceed to do that. So we have h of x equals 2x squared plus 8x minus 10. Now, in order for us to complete the square of a quadratic, the value of a, the coefficient of x squared, must be equal to 1. All right? So the value of a, the coefficient of x squared, must be equal to 1. In this quadratic, that is not the case, and so what we must do is to factor out 2. All right? So this is what we will do. We'll say h of x equals, I'll open a square bracket. Well, before I open the square bracket, I must factor out the 2. So I get 2 square bracket. Then I will give me x squared plus 4x. I will leave some space inside and I will put the minus 10 outside. No, you could actually have factored out the 2 out of the entire expression, but I personally prefer to factor it out of the first 2, leave the minus 10 outside, and then bring it back after. Okay, so this is just how I like to approach this question, but if you prefer to factor out the 2 or the other number in any other question's case, then feel free to do that, all right? But I just personally prefer to factor the 2 from the first 2 terms, or whatever value a takes. So let's proceed now. Now, in order to complete the square of this quadratic, of course, I must add a certain number, right? Now, let's examine the expression inside the square brackets. So this, of course, is a quadratic, which is now of the form ax squared plus bx. And of course, you see that there's no c, so technically c equal to 0. So a is equal to 1. Now we can proceed to completing the square of this expression inside the square brackets. Now what is the value of b? b is equal to 4. In order to complete the square, I must add a half of b squared. So what does that mean? As I said, b is equal to 4, and b over 2 is equal to 4 over 2, which of course gives us 2. So I must add 2 squared. And so in order to complete the square, I must add, let me use a different color. I must add 2 squared. But by adding 2 squared, I change the overall expression inside the brackets. And so therefore, to reverse that change, I must also subtract 2 squared, right? Now by doing that, I managed to actually get these first 3 terms to form what is called a perfect square, right? And so what this will give me is this. I can proceed. Excuse me. I can now say that h of x is equal to 2. I keep my 2 outside. And so this is going to give me x, let me put this as x plus 2. So you can see where that comes from, the x plus 2 all squared. So this piece right here, the first 3 terms, the x squared plus 4x plus 2 squared, essentially will factorize to give me x plus 2 all squared. And of course, I still have my minus 2 squared, which of course is minus 4 outside there. And then I close that bracket and I still have my minus 10 outside. So I'm writing the numbers in those colors so you can actually see where they come from. Now the last step is to just expand the brackets. And so I get that h of x is equal to 2 brackets x plus 2 all squared minus 8, because of course the minus 4 has to be multiplied by the 2 as well. So I get minus 8, and then I have minus 10. And so this gives me 2 open brackets x plus 2 all squared minus 18. And this, of course, as we were told, is now in the form, let me see what they use, a x plus b all squared plus c. So we have a x plus b all squared plus c, all right? So that is in that form 3 months. Now part 2 says, state the minimum value of h of x. Now, whenever you complete the square of a quadratic and you put it in this form, you could automatically read off the y-coordinate of the turning point. And when they speak about the minimum value, they're basically highlighting the fact that this quadratic will shape like this. So it will be a minimum function. And therefore, the turning point or the y value is the minimum point that they're making reference to. And that value right there is the y-coordinate, or this number over here by itself. So this number over here by itself will be the y-coordinate of the turning point, and in this case, it is the minimum value, right? So we can therefore say that the minimum value of h of x is equal to minus 18. So once again, that is the y-coordinate of the turning point. Minus 18 rather, not minus 8, so minus 18. Right, minus 18. So, 1 mark. Now it says determine the value of x for which h of x is a minimum. Now how do we go about doing that? To do that, we must look at what is inside our bracket right here. And of course, we then set that to 0 and solve for x. So in this particular case, we say that x plus 2 equals 0. So x is equal to minus 2. And so this is the value at x, value of x, for which h of x is a minimum. And of course, it basically means that the turning point of this particular function is, of course, minus 2 minus 18. So that would be the turning point. So remember that once you complete the square of a quadratic, you should be able to read off the turning point, right? The y-coordinate is always a term outside by itself. And of course, the x-coordinate is the value which makes this expression inside the bracket equal to 0. Okay? So that is question 1 of that section. So we now proceed to doing question 2. Now, question 2 deals with logarithms, right? So let's look at question 2. And logarithms, of course, is a topic that many students struggle with, right? So let's look at number 2. Number 2 says, given that the log of 6 plus root 12 to base 2 minus the log of 3 plus root a to base 2 equals log 10, find the value of a. So we're given an equation and we're asked to solve for some unknown a. Let's write down the equation. So we have log to base 2 of 6 plus root 12 minus log to base 2 of 3 plus root a, and we're told that this is equal to log 10. Now what do we notice? The logs on the left-hand side are taken to base 2, whereas on the right-hand side we don't see any base. And what does that mean? It simply means that the logs on the right-hand side are taken to base 10. And of course, log to base 10, same thing as log of 10 to base 10, is just 1. Now let's recall some of the laws of logarithm. So from the laws of logarithm, for instance, if we have, for instance, log, so I'm just going to use a random base here, a. So log to base a of b minus log to base a of c would be equal to log to base a of b over c. So what this basically shows is that whenever we are subtracting logs to the same base, it can actually become or be written as log to the base of the quotient of the two expressions, okay? So using that rule in mind, we can then write this as log to base 2 of 6 plus root 12 over 3 plus root a, and this of course will be equal to log 10, right? Now, as I said before, on the right hand side, since there's no base indicated, it means that logs are being taken to base 10, and log of 10 is simply equal to 1. So continuing, we see that log to base 2 of 6 plus root 12 over 3 plus root a is equal to 1. And from the laws of logarithm, what we can now say therefore is that, excuse me. So before we look into that, we can say that, for instance, if log of if log of x to say base 2 equals say 5, this is referred to as a logarithmic form, then this of course implies that x is equal to 2 to the power of 5 and so on. So we've gone from what is called the log form to what is called the index form. And we must do something similar for this particular equation. All right, let me just erase this. So log of that expression to base 2 equals 1. And this therefore implies that 6 plus root 12 over 3 plus root a is equal to 2 to the 1. And so 6 plus root 12 over 3 plus root a is equal to 2. Now, for the sake of cross multiplication, let's put this over 1 and then proceed to cross multiply. So if you cross multiply, it means that we multiply the numerator of one fraction by the denominator of the other. And so we get that 2 times 3 plus root a is equal to 6 plus root 12. And so what this means is we have 6 plus 2 root a is equal to 6 plus root 12. And what do we notice? Because the 6's, of course, are common to both terms, both sides, we can just cancel the 6's, right? And then say 2 root a is equal to root 12. And let's see if we can actually simplify root 12 using surds. Yes, we can. We can say 2 root a, same thing as root 4 times 3, right? And so we get 2 root a is equal to root 4 times root 3. And so 2 root a is equal to 2 root 3, which of course implies that a is equal to 3. So there we have it, a is equal to 3. So we're able to apply the laws of logarithm to solve for this unknown constant a. All right, so that is the part A of that question there. Now let's look at part B. So part B deals with inequalities, rational or fractional inequalities, right? So this question basically says, determine the set of values of x for which 2 minus x over 4x minus 9 is less than 0. Now, what we must remember is when dealing with inequalities like these, is that sometimes we may need to multiply or divide across both sides of the inequality by a particular expression. Whenever we multiply across an inequality by an expression, we must ensure that the expression could never be negative, so that we don't have to worry about the direction of the inequality reversing. Now, what does that mean, for instance? Suppose we have this equation right here. Suppose I just write now a simple equation. A simple inequality. Suppose you have minus x is greater than 3. If I multiply both sides by minus 1, then this becomes x, and this becomes minus 3. But if I forgot to change the direction of the inequality, then this statement would not be correct. Because if minus x is greater than 3, then it simply means that x must be less than negative 3, right? So whenever you multiply across an inequality by a negative number or an expression, or you divide, then you must remember to change the direction of the inequality, all right? And so whenever you have to multiply across an inequality, it is always best to multiply by an expression which you know could never be negative, so you don't have to worry about the direction of the inequality reversing, right? What exactly does that mean? So in this question here, we have an inequality. 2 minus x over 4x minus 9 is less than 0. Let's write it down. So we have 2 minus x over 4x minus 9 is less than 0. Now, it is possible that 4x minus 9 can be negative, right? And so if we were to just multiply by 4x minus 9, we would not be sure if we need to reverse the direction of the inequality or not. However, to avoid that possible confusion, what we're going to multiply across by is 4x minus 9 squared. So we're going to multiply both sides by 4x minus 9 squared. And so when we do this, then this is what we get. 2 minus x over 4x minus 9 times 4x minus 9 squared less than 0 times 4x minus 9 squared. Now I did it on the right hand side too, just to show that we're actually doing the same thing to both sides, right? And on the left hand side, then this basically simplifies to give 2 minus x times 4x minus 9 is less than 0, right? And now we can proceed. Now this of course is obviously an inequality, but what we can do is, for instance, we can take turns, and we can say just let 2 minus x times 4x minus 9 is equal to 0, right? We can say let is equal to 0, and then find the roots. So 2 minus x equals 0, which means that x is equal to 2, or we can say that 4x minus 9 equals 0, which means 4x equals 9, and so x is equal to 9 over 4. So these values would be the solution to the equation. But of course, what we have is not an equation, but an inequality. Now, what is the significance of these values? We will use these values to actually sketch the graph of the quadratic. And how do we know that we have a graph of a quadratic? Now, essentially what we have here is the product of two linear expressions, 2 minus x times 4x minus 9. If we were to expand these brackets, we'd actually get a quadratic. And what we basically are solving is trying to find the region where that quadratic is actually less than 0. In other words, the region of the graph that lies below the x-axis. All right. So let's go ahead and sketch the rough sketch of the graph. Now we must pay attention to something. We must pay attention to the fact that inside this bracket we have minus x and we have 4x. So if you were to expand those brackets, we would get a quadratic which has, let me show you, minus 4x squared. And because it is minus 4x squared, then it's going to shape like this. And the shape of the quadratic, of course, is very important, right? So yes, so we found the roots, and so we can now do our rough little sketch, right? Let's proceed to do that over here. All right, so the roots are 2, 9 over 4, both positive. So we can focus on the positive side of the y-axis, right. So this is our y, this is our x. And the roots are 2, 9 over 4. Now, 9 over 4 is just a little above 2, more than 2. That's about 2 1/4 or 2.25. But we're just going to make it a little bit spaced out for exploration purposes, right? So let this be 2 and let this be 9 over 4. Right. And the graph is going to look something like this. Again, the most important thing is the actual shape of the graph. So it's going to look something like this. It's going to go up and it's going to come back down there. Right. So that's a rough sketch of the graph. And what are we interested in? We're interested in a region that is less than 0. So we're talking about the region of the graph that is below the x-axis. And how do we identify that region or those regions? That region or those regions are going to be to the left of 2 and to the right of 9 over 4. So we see how the shape of the graph becomes important, right? Shape of the graph becomes important. And so the region or the solution would be x is less than 2. Where's my cursor? X is less than 2 or x is greater than 9 over 4. And those are the solutions to our inequality, right? So the set of values of x for which 2 minus x over 4x minus 9 is less than 0. The set of values, of course, x is less than 2 or x is greater than 9 over 4. That is the solution to that inequality. All right. So that was part B. Now let's look at part C. Now part C looks like it involves series, sequence and series, arithmetic or geometric progressions or series. Right. Let's look at the part question. Now it says Alice deposited $4,000 into her new savings account at Bank of Fortune, which pays interest at 8% per annum. The bank's compounded interest is represented by the geometric progression A equals P times 1 plus R over 100 to the power of T, where A is the amount of money accumulated after 3 years, R the percentage rate of interest per annum, and T the positive integer, the time in years. Says determine the number of years it would take Alice's money to at least triple. So let's read the question one more time and write down what exactly we need to find. Alice deposited $4,000 into her new savings. That's the initial deposit, and that would typically be our principal P. So let's write it down. So we have the principal P is equal to 4,000. We can leave off the dollar sign for now. 4,000, which pays an interest rate of 8% per annum. So the interest rate R is equal to 8% per annum. For the purpose of the compound interest formula, that's going to be 8 over 100, which of course is written in the formula there, right? So R over 100. Anyway, so R is equal to 8. They actually involve or include R over 100. So we'll put that in the formula. So let's leave it at that. Right. And of course, so we're told that A is the amount of money accumulated after 2 years. And of course, they want us to find the number of years it would take Alice's money to at least triple. So let's write down the compound interest formula. So we have the accrued amount, A is equal to P times 1 plus R over 100 to the power of T. So let's put in our values. A is equal to 4,000 times 1 plus 8 over 100 to the power of T. Right? Let's simplify the expression inside the brackets first. And so we get that A is equal to 4,000 times 8 divided by 100, that's 0.08. So this gives us 1.08 to the power of T. Now, let's go back to the question. The question says, determine the number of years it would take Alice's money to at least triple. So at least triple means that our accrued amount, A, must be greater than or equal to 3 times 4,000, because 4,000 is the initial deposit as a principal. And so basically, it means that A must be greater than or equal to 12,000, right? So what we can basically say is, for instance, right? So it's, I mean, another way of saying this is that A over 4,000 must be greater than or equal to 3, right? Something like that, yeah. So A over 4,000 must be greater than or equal to 3. So, right, yeah, so let's proceed. So there's many ways we can actually write this equation. So we can basically also say that, well, 4,000 times 1.08 to the power of T is greater than or equal to 12,000, which means that if we divide both sides by 4,000, then we have 1.08 to the power of T must be greater than or equal to 3, right? Now, for the purpose of solving this equation, we're going to let 1.08 to the power of T be equal to 3. So say let 1.08 to the power of T equals 3. Now, how do we go about solving this equation? We have to take logs of both sides. So taking logs, we say log of 1.08 to the power of T is equal to log 3. And of course, we're taking logs to the base 10. We're taking logs to the base 10, and therefore this means that T log 1.08 is equal to log 3, and therefore T is equal to log 3 divided by log of 1.08, right? Let's go ahead and work that out. So we see that T is equal to log 3 divided by log of 1.08. And so let's see what that gives us. So log 3 divided by log 1.08, and this gives us 1.95. So when it triples, essentially takes 1.95, but of course, tell us that T is a positive integer, and so we must round to the next whole number, which of course is 2, right? So it will take Alice approximately, well, 2 years for her money to triple, all right? 2 years? 2 years? Seems a little bit small, but anyways, let me check our maths a little bit. Yeah, 2 years takes like a little bit small, but anyways, let me check it. Let me check our equation. A equals P1 plus R over 100 to the power of T. A equals 4,000, 1 plus 8 over 100 to the power of T, right? So that means that 4,000 times 1.08, yeah, A must be equal to 3 times that. So therefore, 4,000 times 1.08 to the power of T must be greater than or equal to 12,000 because it says at least triple, right? So therefore, that must be 1.08 to the power of T must be greater than or equal to 3. Come on, something not right here. 1.08 T to the power of 3. So T log 1.08 equals log 3. T equals log 3 log 1.08. Let me check my calculator again. Maybe the calculator gave me something wrong. I think so, yes. So the calculator's off because I know it take far more than 2 years for that to triple at that interest rate. So this calculator, may have punched in the device on the calculator wrong. Did not put a bracket. So let me see. Log 3 divided by log 1.08. Right, so I know something was off. Yes, could never be 2 years. So this is now giving me approximately 14.3. So it's approximately 14.3, which of course we're going to round to 15, right? We're going to round to 15. So T is approximately 14.3, which is approximately equal to 15 years, right? So at that rate of interest, it will take approximately 15 years for Alice to see a tripling of her initial deposit. Okay? All right, so this is the end of question 2 and the end of section 1 from paper 2 of 2021 for CSEC Admits.